Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Sharom and my other two group member is Muhammad Afiq Faus bin Famizab and Ahmad Shazwan bin Jeffrey. Our group will present about progress monitoring at construction sites using UAV technology with the help of Supervisor Prof. Madhyati S. Masri bin Kamil, and this is our final year project.
For introduction, construction is a large and vast industry that involves many parties directly or indirectly. To identify whether the deadline can be met and the project's budget is used in a controlled manner, every member involved in the project needs to know the current progress at the construction site compared to the project's plan. Monitoring progress for large-scale construction sites is very difficult and time-consuming. Rational decision needs to be made by those involved in construction management for each issue that arise in a project. For example, obtaining accurate information with respect to the work in progress. Traditionally, digital cameras are used to capture image at development sites. This method has limited coverage area and there are areas that cannot be reached by ordinary camera. This research focuses on the use of unmanned aerial vehicle UAV as an alternative to digital camera for capturing photo of building sites from a height of 80 to 90 meters above ground level. Orthophoto can make it easier to track the development of construction project. The use of technology and robotic systems such as UAV technology for monitoring and structural inspection may be an effective way to increase the efficiency and accuracy of structural integrity assessments. The use of UAVs can facilitate monitoring activity throughout the construction process by using UAV capacity to carry cameras and capture high-quality video. The UAV is operated automatically using advanced detector and software, as well as a global positioning system (GPS) that can be programmed in a stable, multitasking state. UAV can be used as a platform to effectively collect accurate large-scale terrain modeling image.
I will present about material and method. Phantom 4 Pro V2.0 was used along with PIX 4D capture software to capture image of the construction site area. As shown in figure, Taman Impianan Jalan Kurai Sedana, mile 26 in Johor, which was still under construction, was selected. For this investigation, the UAV was flown above the construction site. Data collection. Before using DJI Go 4, the smartphone was linked to the remote controller and UAV. DJI Go 4 is a software that links to UAV camera to the Global Positioning System (GPS). This was accomplished by using the coordinate calibration setup to ensure that the UAV receives the GPS signal. This step facilitated the navigation of the flying system. In terms of safety of using such a flight system, the come home function ensures a safe landing in the event that the link between the ground station and the flying system is lost. Before starting the PIX 4D capture software, the link was verified on DJI Go 4 app. A project file was produced during the PIX 4D capture process to begin the grid mission as shown in figure, which include double grid and single grid. To create a 2D map, the mission grid was chosen, and the coverage area for the single grid was updated in 80 minutes 21 seconds at a height of 90 meters above ground level, covering an area 321 multiplied 750 meters. The correct time for the double grid is 11 minutes 20 seconds at a height of 80 meters above ground level, covering an area of 400 multiplied 93 meters. To take photographs with a plane perspective of the whole region, the camera was automatically rotate 90 degrees vertically. Data collection was complete monthly at the same location on 8 April 2022, for 14 May 2022 and 3 June 2022. Image processing. A total of 387 images captured using the UAV were processed in PIX 4D Mapper and Global Mapper. This stage comprised choosing the appropriate template for the UAV UAV flight position to display in the map view region using photogrammetry techniques and the PIX4D mapper program, as shown in figure. The UAV flying interval is shown on the video screen. Sequential processing, which is a fundamental goal of image processing, comprises initial processing, point and net clouds. Digital surface model. Sequential processing, which is a fundamental goal of image processing, comprise sequential processing, which is initial processing, point and net clouds. Digital surface model, ultimately automosaic image generation. This automosaic image was used for the monthly analysis of the building progress.
I will present about automosaic image generation. Okay, automosaic image generation is the image were recorded by the UAV and were transferred into PIX4D mapper. So, this is the overlapping image or process to produce high quality 3D with better precision and higher resolution. With the availability of high-resolution image, the volume of excavated soil can be calculated and the development of the construction site can be determined accurately. The image were then merged to produce high-resolution automosaic image. As we can see, the example of the image in the division of the study area.
For result and discussion, the image taken from April to June showed that the percentage of project progress increased and continued from the first month to the third month. For the entire project, G2 for Area 2 and D1 for Area 1 progress is the most from April to June, where almost all work was concentrated in those areas. Many development occurred in Areas 1 and 2 during the 3 months. Each section within the area showed an increasing percentage of work, even though they were sections with slow progress. This picture shows construction site display for Area 1. A for first month on 8 April 2022, B second month on 14 May 2022, and C for third month on 6 June 2022. This picture shows construction site view display for Area 2. A first month on 8 April 2022, B second month on 14 April 2022, and C is the for third month on 6 June 2022. For most active area of work progress, based on the overall image from April to June, the percentage of project progress increased and continued from the first month to the third month. For the entire project, D1 was the most active section for Area 1. This figure showing progress from month 1 to month 3, indicating that work was focusing on the area. Based on visual observation, the progress at D1 in April involved the installation of molds and beam columns to erect the second floor of the building. In May, the floor formwork for the second floor was installed. By June, the floor cementing process for the second floor was complete. For most active area of work progress, the most active area for Area 2 is the section G2. This figure showing progress for April to June, indicating that work was focused on the area. Based on visual observation, the progress at G2 in April involved the installation of molds and beam columns to erect the second floor of the buildings. The floor area was already fully cemented, but the beam poles had not been installed. In May, the installation work of beam columns was complete, and the installation of floor formwork for the second level was started. By June, the installation of formwork and iron grills for the second floor was 100% complete.
Calculation of volume data using global mapper. It is important to ensure that the area and parameter remain the same in each UAV data. Acquisition image from April to June when using the global mapper software, so that the accuracy of the study area does not change to determine the amount of volumetric data. The first picture shown, area taken using UAV is 331 times 750 meter. The actually area, the excavation area, is taken to calculate the data of the earthwork. The perimeter is 482.77 meter in the red marking. So this is differences of excavation areas in 3D map of the same format in April, May and June. From these three pictures, we can see the differences of excavation for 3 months. So we go for result and discussion. 1,250.053 meter cube soils have been excavated in May. This is because on the first flag, the total volume of soils was 30,754.75 meter cube, then decreased to 29,404.697 meter cube on the second flag. In June, a total of 122.935 meter cube volumes of soil had been excavated, as the volume also decreased to 39,381.762 meter cube. In conclusion, different approach to track construction progress by using orthophoto image taken using UAV. An accurate monthly construction progress can be calculated. The suggested approach demonstrates an easy way to keep track of project progress. This approach is superior to others because it makes progress tracking simple for site managers or engineers. I think that's all from us. Thank you.